Welcome to The Explainer. We're always hearing about these incredible AI breakthroughs and data-driven discoveries. But today, we're going to pull back the curtain on the part nobody ever really talks about. The messy, complicated, and honestly, the most crucial part of the whole process, getting the data ready in the first place.
I'm sure you have, right? It's a pretty simple idea. The quality of what you get out is completely dependent on the quality of what you put in. If you try to bake a cake with bad ingredients, you're just going to get a bad cake. And in the world of data science and machine learning, this isn't just a cute saying, it's basically a law of physics. You could have the most powerful, most sophisticated AI on the planet, but if you feed it junk data, you are absolutely going to get junk predictions. It is that simple. Rushing past this step is just a recipe for total disaster. So, just how big of a deal are we talking about here? Well, look at this number, 60%. In a typical data project, that's how much time and effort is spent just on preparing the data. Think about that for a second. More than half the work is done before you even get to run a single cool algorithm. It's huge.
And that massive hidden effort, well, that's exactly what we're calling data's dirty little secret. So let's get into it and expose the mess for what it is. All right, let's play doctor and diagnose this mess. Before we can even think about cleaning anything up, we first have to understand what dirty data actually looks like when you find it in the wild. The truth is, data you get from the real world is almost never perfect. It's usually this chaotic jumble of different problems. And as you can see, we've got four main culprits: data that's incomplete, noisy, inconsistent, or redundant. So let's break down what each of these troublemakers actually is. First up, we've got incomplete data, and it's exactly what it sounds like. You've got these frustrating, empty gaps in your records. Maybe a piece of equipment failed to record something, or, someone just got lazy and skipped a field on a form. Whatever the reason, you're left with a blank space where some really important information is supposed to be. Next on our list is noisy data. Think of this like static on an old TV. It's just plain wrong information corrupting your data set. That example of a salary being negative $10? That's a classic. This noise can sneak in from anywhere: simple human typos, faulty sensors, or even glitches when data is being sent from one place to another. Then you've got inconsistent data. This is where the information you have just flat out contradicts itself. I mean, look at this example. You're 42 years old, but your birthday was in 2010. No way. It just doesn't add up. This also pops up when you have different formats for the same thing, like one system codes New York as NY, and another spells it out. To a computer, those are two totally different places. And wow, this table right here, it's like the perfect storm of dirty data. It shows you how all these problems can be tangled up in just a few lines. You've got inconsistent names for the same person. Is it Bill or William? You've got incomplete data with that question mark for a birthday and the blank age. And of course, there's that classic noisy data, that impossible negative salary. This is the kind of puzzle data scientists have to solve every single day. Okay, so we've seen the chaos. How on earth do we bring some order to it all? Well, thankfully, it's not just random guesswork. There's actually a proven 4-step framework for turning this kind of mess into a super high-quality asset. I absolutely love this analogy. A chef can't just throw ingredients in a pan. No, they have to wash the veggies, trim the meat, measure everything out. All that prep work comes first. And that's exactly what data pre-processing is. It's the essential prep work before the real cooking, the analysis, can even begin. And here's the roadmap for that journey. It's a 4-stage process. First, we start with data cleaning, tackling all those errors we just talked about. Then we move to data integration, which is where we pull together data from different sources. After that, we do data transformation to get everything onto the same scale. And finally, if we have a giant data set, we might use data reduction to make it a bit more manageable. So let's see some of this in action. All right, theory is great, but let's get our hands dirty. We're going to zoom in on a couple of really common scenarios and see how we can actually turn that messy data into something meaningful. So what do you do when you hit one of those gaps in your data set? This is probably one of the very first problems you're going to have to solve. You've basically got two main choices here. On one hand, you can just delete the entire row. It's simple, it's fast. But the big risk is that you might be throwing away a lot of other valuable information in that same row. On the other hand, and this is pretty common, you can try to fill in that gap. You could use a simple placeholder like unknown, or you could get a bit fancier and fill it with, say, the average value for that whole column. It's still an educated guess, but it lets you keep the rest of the record. Okay, so we've plugged the gaps. But what about another really common problem? What happens when your data is just on completely different scales? I'm talking about trying to compare something like a person's age, which might be 41, to their annual salary, which could be 92,000. Just look at this table. The age is in the double digits, but the salary is way up in the tens, even hundreds of thousands. Now, if your algorithm is trying to measure the distance between customers, those huge salary numbers are just going to completely overpower the smaller age numbers. Your analysis would basically ignore age altogether, and that is a huge problem. The solution here is a really clever trick called normalization. What it does is it takes all these numbers from different scales and it squishes or stretches them so they all fit into a standardized range, which is usually between 0 and 1. This puts every feature on a totally level playing field so that salary doesn't just drown out the age. And there you go. This is the result. After you normalize it, look what happens. The customer with the lowest age and lowest salary are now both at 0. The ones with the highest are both at 1, and everyone else falls somewhere in between. Now these numbers are directly comparable, and the analysis will be much, much fairer. And finally, a quick word about outliers. These are those data points that are just way out there, totally different from everything else. That negative salary we saw earlier, a perfect outlier. We can use techniques like clustering to automatically spot these weirdos, which often show up as lonely points far away from the main crowd. This lets us either remove them or investigate what's going on. So, after all that work, all that cleaning and integrating and transforming, what's the big payoff? I mean, why go through all this trouble? This chart says it all. It is all about accuracy. If you build a model on that raw, dirty data, maybe you only get 65% accuracy. But that exact same model, when you feed it clean, properly prepared data, it can jump all the way up to 92%. We're not just talking about a small improvement. This is the difference between a project that works and one that completely fails. It's about getting insights you can actually trust. So I'll leave you with this question to think about. The next time you read a headline about some amazing AI discovery, take a second and ask yourself, I wonder what the data behind that discovery looked like. Because now you know the real secret. The magic isn't just in the fancy algorithm. It's in the clean, well-prepared data that makes it all possible.